Okay, today our learning targets are I can solve real world problems involving decimals and I can estimate decimal sums and differences to check if my answers are reasonable. Real quick, before we start this, we need to review some vocabulary around rounding. And we're going to practice one whole number rounding problem to kind of remind you of doing that before we do it with decimals. So, first of all, estimation means to find a value that is close enough to the right answer, and usually this involves some thought or calculation. Definitely going to involve some calculation today. So you are not just saying, I think or I guess. You are going to get close to an answer by using some other math or place value strategies. Okay. Next, reasonable means agreeable to reason or sound judgment. That means it makes sense. So we're going to be doing this with our answers. Check to see if they are reasonable. And then we're going to use rounding to do our estimation. So rounding means to make a number simpler, but keep its value close to what it was. We worked on rounding earlier in our decimal unit. Okay? First, go ahead, write this on your whiteboard. We're going to practice this. We're going to review estimation with just one whole number problem first. Now, the tricky part about estimation is not really the rounding or the addition or subtraction that comes after the rounding. It is, how do you decide what place value holder to round to? Okay, so you're going to be doing a lot of those decision making things today. Now, I can't tell you for every problem in fifth grade, you're going to round to the nearest 10 or you're going to round to the nearest whole number. You kind of got to make that choice for every problem, and every problem is a little bit different. So hopefully you will gain some comfort in doing that today. So first we're going to start with, we're going to estimate the difference between 43 and 28. Now in this case, we're going to round both of these to the nearest 10. Okay, so if we do our 10 above would be 50. If we keep it the same, it would be 40. And we're going to look at this 3 to make our rounding choice would be 40. So I'm going to write my problem here again with my new rounded numbers. And we're going to subtract from that either 20 or 30. What does an 8 tell you to do? An 8 tells you to go up to 30. Okay? Now we are going to do this subtraction. So 40 minus 30 is 10. This is our estimated answer, our estimate. Now our actual answer is going to be different because look at how we change these to do our rounding. But let's go ahead and check out our actual answer because it should be close to or reasonable around 10. So we're going to do 43 minus 28. I'm going to borrow and regroup here. 13 minus 8 is 5, and 3 minus 2 is 1. So our actual answer that we calculated is 15. Are 15 and 10 pretty close together? Definitely. That means our answer, yay, is reasonable. Okay, so you're going to be doing this with decimals. It's going to be a little bit trickier. So let me go ahead and scroll down. And let's first work on this problem. Okay, now, like I said, you're going to have to make a choice about what are you going to be rounding to make your choice. So we're not going to do this subtraction. Well, actually we are. But first thing we're going to do is we are going to find our estimated answer. Or our estimate. Okay. And to do that, we're going to look at these two numbers and do some rounding. Now, I think it would be completely reasonable for us to, in this problem, maybe not round to the nearest whole number, because if we rounded to the nearest whole number, this would be 0 and this would be 4. So the 4 minus 0. I think instead what we should do is round to our nearest tenth. So I'm going to underline the tenth. I'm going to box my hundredth. And then we're going to do that rounding. And I'm going to do it right here. And then I'm going to rewrite it right here to get my estimated answer. So think about all the practice you've done with rounding. That 3 stays the same. And we are just going to keep this 7 as either 10 or 8. Or sorry, 10 or 8. This tenths is either 7 or 8. And the 8 tells me to raise it up. So our estimate, we're going to do 3 and 8 tenths minus. And now I'm going to look at this. Does this stay at 1/10 or are we going to bump it up to 2/10? What does a 9 tell you to do? It tells you to bump it up to 2/10. Okay, now we're going to implement all those decimal addition subtraction strategies that we've been doing, and we are going to subtract. See how these numbers are different than these. I'm going to regroup here. I'm going to turn one of my ones into 10 hundred, or sorry, tens, and I have 8. Just kidding. I don't have to do that, Miss Brocker. Wake up this morning. I'm going to go back to that. You might be thinking, what is this crazy lady doing? You can subtract 8 from 2. And you are right. I'm not going to redo this whole video just because I made one mistake. Hopefully, this is a model for you to pay a little bit better attention. 8 minus 2 is 6. And our decimal point in our difference and 3. So here is our estimated difference, 3 and 6/10. Now, what we're going to do here is we're going to find our actual answer. And we're going to use our estimated answer to see if our actual answer is reasonable. Okay, so we're going to do 3 and 78 hundredths. And from that, we're going to subtract 192 thousandths. Okay, remember all that hard work we've been doing with decimals. Make sure you use those strategies. So I can't take away 2 from 0. I'm going to come over and borrow from this 8. 8. Now I can't take away 9 from 7. So I'm going to turn this into a 6, this into 17. 6 minus 1 is 5. And 3. Oh my goodness, guys, look at this. 3 and 588 thousandths. Is that really close to 3 and 6/10? Yes. Yay! Yay, we did it right. This is a wonderful example of how we can use our rounded answer, our estimate, to see if our real answer is reasonable. Okay, so when we do our word problems today, I want you to make sure that you are checking this out, okay? Okay, we're going to go ahead and do just 1 or 2 word problems real quick. So I'm going to start by reading this to you, and then I want to show you a strategy that I use to do decimal word problems, and you've probably seen it before, okay? Mr. Rowe is running the mile on the track behind Northport. His first lap takes him 3 and 4,573 10,000ths minutes. His second lap times in at 3 and 72,841 10,000ths minutes. How much time did it take him to complete his run? In my mind, the biggest challenge that happens with word problems is deciding what to do and how to use your information. So, first of all, we need to decide, what is this question asking us to? Okay. Now, I am a big fan of underlining the question. So I'm going to do that first. So I'm going to underline in red. And I think this would be a good strategy for you to start doing too. I know it's going to be hard because you won't copy this whole problem on your whiteboard today, but I just want you to practice it, especially when you get to the MCA in a couple weeks. Okay. So we are really trying to figure out how much time did it take for him to complete his run. Now, some bar modeling might also be useful here. So I could draw a little bar model to show me this problem. I know that he ran just 2 laps. Lap 1 took him 3, 4, 5, 7, 3. I'm not going to run out of room right here. And 3 and 72,841 tens, hundreds, thousands, 10,000s, 100,000s. What we are trying to figure out is, what is that combined? What is that total? Okay. How much time did it take for him to complete his run? So what operation would you do to find the length of this whole bar? You would do addition. Okay. Second thing we need, we're going to go through and circle the information that we need to solve that problem. So all I need to solve this is these 2 values. And then what we are going to do is we are going to add them together. Third step is to solve by showing your work. So what I'm going to do first is I'm going to set this problem up with the decimals, and we're going to find our answer. And then we are going to estimate using rounding to see if our answer is reasonable. Now remember, with addition, we don't have to do a lot of work to see which one of these goes first, because order does not matter. And I'm still being really careful to line up my place value holders. I'm going to fill in anything that does not line up with zeros. And then we are going to start adding. Okay, so we're going to start all the way over here. And 0 plus 1 is 1. 3 plus 4 is 7. 7 plus 8, regrouping, is 15. 6 plus 2 is 7. Oops, it's not 7. Is 8. I originally was just looking at my 5 plus 2. I forgot I carried that 1 over. So be careful. That's your sign, okay? 7 plus 4 is 11. And 3 plus 3 is 6, plus 1 is 7. Okay, and then lastly, one thing we want to do is put a label on this. So we're looking for minutes. So I'm going to write on here minutes. I'm going to abbreviate it. Okay, now, next step for us to do. So here's our answer. We're like, yep, we're done. No, I want you to start now that you know how, estimating your answer. Now, what I think would be a good choice for us to do in this problem specifically would be to look at, because our answer, see how our answer goes into the tenths, hundreds, thousands, 10,000s, 100,000s. Let's look at these values to do our estimating, okay? And so we're going to round these, both of these values, to the nearest hundredth, okay? Nearest hundredth. And we're going to do that by using this place right here. Let me do this in red. We're going to look at our thousands place to make our rounding choice, okay? So first I'm going to do this one. Put this one on top, okay? So we have 3 and 45 hundredths, or 3 and 457 thousandths. So I'm going to look at this thousands place to make my rounding choice. That tells me to bump it up to 3. We're going to keep our 4 tenths, and that 5 is either going to stay a 5 or it's going to bump up to a 6. A 7 tells us to raise the score. Okay, we're going to do the same thing with that bottom number, and now we're going to be looking at this 8 to make our rounding choice. Is this going to stay at 3 and 72 hundredths or go up to 3 and 73 hundredths? It is going to go up to 3 and 73 hundredths. Okay, now let's add these together, and what we should see is that it is close to this. This answer is reasonable. If it is way off, then we made a mistake. Okay? 9, 1, 1, and 7. Okay, our estimated answer is 7 minutes, and I'm not going to say 19 seconds, but 19 hundredths of a minute. Is that pretty close to 7 and even just look at this part right here, 18 hundredths of a minute? Yes. So that means yes, our answer is reasonable. Woo! Nice job.